Why are planets round instead of flat? If the Earth were flat, then I know why the dinosaurs went extinct. In fact, in the 21st century, there are still millions of people around the world who believe that the Earth is flat. They think the Earth is a giant flat disk, and that Antarctica is an ice wall surrounding the disk. All photos of Earth taken from the space station are fake. I want to say that if the Earth really were flat, then cats would have pushed everything off the edge. In the early universe, there was no such thing as shape, because stars and planets had not yet formed. There were only clouds of thin Gawain and dust floating in the void. But the existence of gravity changed everything over billions of years. As long as there is mass, gravity will slowly pull matter together, drawing scattered dust toward a central point. On cosmic scales, billions of years are just a blink of an eye. Molecular clouds begin to collapse, matter gathers more and more, density increases, and gradually the first spherical stellar cores form. During this long evolution, we can observe a pattern quietly emerging. All objects large enough start becoming round. Gravity is isotropic. It is the same strength in all directions. In other words, the gravitational pull on every point of a celestial object is directed toward the center. It is perfectly symmetric, with no directional preference. This isotropic force pulls every point on the surface toward the center, tending to equalize distance from the center. Therefore, as long as the mass is large enough, gravity will continuously compress a planet, flattening all bumps and filling all depressions, until the object reaches its most stable, lowest energy shape, a sphere. But in reality, not all celestial bodies are perfect spheres, especially planets. For example, Earth is not a perfect sphere, but an oblate spheroid flattened by rotation. As Earth rotates, the centrifugal force near the equator counteracts part of gravity, pushing the surface outward, while the poles without centrifugal force are pulled closer to the center, forming a noticeable oblate shape. Earth's equatorial radius is 6,378 kilometers, while the polar radius is only 6,357 kilometers, a difference of 21 kilometers. Jupiter's flattening is even more dramatic because it rotates extremely fast, taking only 10 hours for one full rotation, resulting in a difference of over 4,500 kilometers between its equator and poles. In other words, gravity makes planets round and rotation makes them flat, ultimately forming the stable and classic shapes we observe. Stars, however, are almost perfect spheres because they are balls of superfluid plasma. Planets are solid bodies made of rock, metal, and ice, while the interiors of stars reach tens of millions of degrees, turning all matter into highly fluid plasma. The extremely high pressure inside stars makes them much more able to become perfect spheres. Stars follow a core physical condition. Pressure gradients push outward while gravity pulls inward, and the two reach equilibrium, hydrostatic balance, which prevents stars from retaining any bumps or deformations, ultimately making them even closer to a perfect sphere than planets. At this point, some curious viewers may ask why some small celestial bodies look strange in shape. For example, Mars's moon Phobos looks like a walnut. This is because they are too small. Their gravity is not strong enough to overcome the structural strength of their rocky material. Whether an object can become round depends on one threshold, the hydrostatic equilibrium limit. When a celestial body's diameter is less than 600 to 800 kilometers, its gravity is too weak and its rocky structure too strong for bumps and pits to be smoothed out. It will naturally form irregular shapes. But when it exceeds this size, gravity can overpower rock, ice, or metal strength, forcing all structures into a spherical shape. Therefore, dwarf planets like Ceres and Pluto are spherical, while asteroids like Eros look like giant peanuts. So whether a celestial body can stay round is actually a matter of physical strength. Strong gravity means round, weak gravity means random shapes. In other words, becoming spherical is the path for a celestial body to advance into a planet or star. The universe does not pursue beauty, it pursues stability. This is an unspoken rule of the cosmos. When your mass is strong enough, you will become a perfect sphere.